Have you ever wondered how a small thing like electricity powers our entire world? From the moment we wake up, we're surrounded by the influence of electricity. It brews our coffee, illuminates our homes, keeps us connected to the world through our devices, and even warms us on chilly nights. It's a constant companion, a silent force that makes modern life possible. But what is electricity? In the simplest terms, it's a form of energy resulting from the existence of charged particles. These can be either electrons or ions, and their movement creates an electric current. It's this current that powers our appliances, lights our cities, and keeps us connected. Electricity is the heartbeat of our modern world, the unseen force that powers our everyday lives. From the smallest microchip to the largest power station, electricity is the energy that keeps our world running. So, what exactly is this powerful force we call electricity, and how does it come in different forms? If you thought electricity is just one type, prepare to be surprised. Electricity, a fundamental force that powers our world, is more than meets the eye. In fact, it comes in two distinct types, static and current. But what's the difference between them? Let's find out. Firstly, let's talk about static electricity. The term static means stationary or not moving, and that's exactly what static electricity is, an accumulation of electric charge that remains at rest. You've likely encountered static electricity in your everyday life. Ever walked across a carpet and then gotten a small shock from touching a doorknob? That's static electricity in action. It's created when certain materials are rubbed together. The friction causes electrons to be transferred from one object to another, resulting in an imbalance of positive and negative charges. This imbalance causes the objects to attract each other, much like magnets. A more dramatic example of static electricity is lightning. During a storm, an imbalance of charges between the ground and the clouds results in a massive static discharge, resulting in the bright flash and thunderous boom we associate with lightning. Now on to the second type, current electricity. Unlike its static counterpart, current electricity is all about the movement of electric charge. It's this type of electricity that powers the devices we rely on every day, from your smartphone to the refrigerator. Current electricity occurs when there's a flow of electric charge, typically along a wire or conductor. This flow is driven by a power source, like a battery or a generator, and it's this consistent movement of charge that allows us to light our homes, cook our food, and stay connected to the world. In essence, static electricity is a stationary buildup of charge, often released in a sudden spark or shock, while current electricity is a steady flow of electric charge, utilized to power our modern world. Thus, the electricity that shocks you and the one that powers your devices are fundamentally different. While static electricity is fascinating, it's current electricity that truly lights up our lives. Let's dive deeper into this electrifying world. Current electricity is a dynamic force, a ceaseless flow of electric charge. But did you know that it has two distinct types? Yes, meet direct current and alternating current, the two superheroes of our modern world. Let's start with direct current, or as the cool kids call it, DC. Imagine a flowing river. Its water moves in one direction, from the source to the sea. Similarly, in direct current, the electric charge flows in one steady unidirectional path. This steadfast and consistent nature of DC makes it the perfect choice for devices that need a stable supply of electricity, like your beloved smartphone or the batteries that power your remote control cars. But what about the electricity that powers your home? Enter alternating current, or AC. Unlike its DC counterpart, AC is more like a pendulum, swinging back and forth, changing its direction periodically. This constant change of direction allows AC to travel long distances without losing power, making it the go-to choice for power supply systems. Think of every time you've plugged in an appliance at home. That's AC at work. Now you might wonder, why two different types of current? Well, it's all about efficiency and suitability. While DC's constant flow is perfect for sensitive electronics that need a steady power supply, AC's ability to travel far and wide without losing power is ideal for powering our homes and cities. So, the next time you charge your phone or switch on a light, remember the unsung heroes, DC and AC, working tirelessly behind the scenes, making our lives easier and brighter. So, the electricity that powers your smartphone and the one that lights up your home are not the same. Now that we've harnessed the knowledge of electricity, let's ponder over its implications. Understanding the different types of electricity isn't just about knowing the science behind it, but also about recognizing its profound impact on our daily lives and the world at large. The power of this understanding is like holding a key that unlocks a multitude of possibilities. Take, for instance, the design and use of electrical devices and systems. From the smallest transistor in a computer chip to the largest turbines in a power plant, the principles of electricity guide their design and operation. Knowing how static electricity works helps us to manage and prevent its disruptive effects on electronics. Understanding current electricity is fundamental to designing efficient circuits and devices that we use every day, from your morning coffee maker to the electric car you drive. Furthermore, this knowledge is instrumental in advancing technology. It's the understanding of electricity that led to the invention of the telegraph, radio, television, computers, and the internet. Every new device, every technological leap forward, is built on the foundational understanding of electricity, but the implications extend beyond technology. Our understanding of electricity is also crucial in promoting sustainability. As we grapple with the challenges of climate change, electricity plays a pivotal role in the transition to cleaner, renewable sources of energy. Understanding how electricity can be generated from the sun, wind, or tides is leading us towards a more sustainable future. In essence, understanding electricity is not just about grasping a scientific concept, it's about appreciating the power that lights up our homes, runs our industries, drives our technology, and will guide us towards a more sustainable world. So, the next time you switch on a light or charge your phone, remember the incredible science that's powering your world.